In this question, we're told that the lengths of a random sample of 120 limpets taken from the upper shore of a beach had a mean of 4.97 centimeters and a standard deviation of 0.42. The lengths of a second random sample, this time there were 150 limpets, were taken from the lower shore of the same beach, and they had a mean of 5.05 and a standard deviation of 0.67 centimeters. Firstly, we're asked to test, using a 5% level of significance, whether or not the mean length of limpets from the upper shore is less than the mean length of limpets from the lower shore. Okay, so let's get started. I'm just going to summarize the data that we have already. So the sample size for the limpets at the top or the upper shore is 120. Their mean is 4.97 and their standard deviation 0.42. Sample size for the lower shore, 150. Mean that we were given, 5.05. And the standard deviation that we were given, 0.67. Let's start by setting up our hypothesis. The null hypothesis, the means are equal to each other. Or we can say that mu y minus mu x is going to equal 0. The alternative hypothesis, mu y is greater than mu x, or mu y minus mu 1 is greater than 0. We're doing a 5% level of significance. And actually, just right here, I'm just going to calculate y bar minus x bar. So this is our test statistic. And we get 5.05 minus 4.97. It's 0.08. So it's a positive value. Is it positive enough? Is it convincing enough for us to reject the null hypothesis? Let's get a distribution for the difference of these means. So we'll go for y bar minus x bar, and that should follow a normal distribution where the mean is 0, and here we have the standard deviation, 0.42 squared over 120, plus 0.67 squared over 150, and the square root of that is going to be the standard deviation. Square that to get the variance. Okay, so normal distribution diagram as usual, mean of 0. Here's our test statistic, our observed value. What's the probability that it's greater than that? Okay, so we can do this on our calculators. NCD, minimum of 0.08, maximum 10,000. And we're going to need our standard deviation value, this long fraction root expression, and a mean of 0. All of this into the calculator gets a probability of 0.1152. So 11.5%. It's actually quite a high chance, a high probability of this happening. Since this is bigger than 0.05, it is not a significant result. So let's make our two conclusions as usual. The first one being the mathematical conclusion that we do not have enough evidence to reject H0. And following up with the contextual conclusion that there's not enough evidence that the mean length of the limpets from the upper shore is less than the mean length of limpets from the lower shore. In part B, we've actually been asked to state two assumptions that we made to carry out our test in part A. Firstly, we did assume that they were independent, two independent samples from each other. And secondly, we assumed that the sample population that we were given in the question matched the population standard deviation. So we just substituted it straight in as the value we were using. We wouldn't have been able to calculate the unbiased estimator of the population variance since we don't have all of the original data of the sample. We don't have individual x values to calculate the sum of x or the sum of x squared. So we do need to make the assumption that this sample standard deviation will match or be a good indicator of the population standard deviation.